Question 1, we've got the grouped frequency table here showing the stem lengths in centimeters for 120 tulips. We've drawn a histogram to represent this data, and we know that the 40 to 42 class is represented by a bar having an area of 16.5 square centimeters, and we need to determine the exact area of the 42 to 45 bar. Well, we know that in a histogram the area is proportional to the frequency. So the 40 to 42 class has a frequency of 12. So we know that 12 are being represented by 16.5 squared centimeters, and the 42 to 45 class has a frequency of 18. So we're saying 18 will require x squared centimeters. So we've got that x is 18 times 16.5 over 12, which gives an answer of 24.75 squared centimeters. In part B, we are told that the height of the tallest bar in this histogram is 10 centimeters, and we need to determine the exact height of the second tallest bar. Well, we know that in a histogram, the height is the frequency density, so I will go and calculate the frequency density for each of these classes. So we've got the class width and the frequency density. The class width for the 40 to 42 is obviously 2. Then for the 42 to 45 is 3. Then it's 5, 5, 3, 2. And to find the frequency density, we simply do frequency divided by class width. So 12 divided by 2 is 6. 18 divided by 3 is 6 again. 23 divided by 5 is 4.6. 35 divided by 5 is 7. 24 divided by 3 is 8. And 8 divided by 2 is 4. So we can see that the tallest bar is the one with the highest frequency density. So this had a height of 10 centimeters, and the second tallest bar is obviously the 50 to 55 class. So let's call the height of this y centimeters. And therefore, we have that the frequency density of 7 corresponds to a height of y centimeters, whereas a frequency density of 8 corresponds to 10 centimeters. And therefore, we have that y is 7 times 10 divided by 8, which gives an answer of 8.75 centimeters. See, we've got that the lower quartile is 45, and we need to use linear interpolation to estimate the median Q2 as well as the interquartile range. Well, starting with Q2, I will start by evaluating n over 2, which in our case is 120 over 2, which gives an answer of 60. And therefore, I wish to interpolate the value corresponding to the 60th position. Now, to do that, I'll go back to my frequency table and consider the cumulative frequencies. So I will be summing up the frequencies as I go down. So we start with 12 plus 18 is 30, plus 23 is 53, plus 35 is 88, then 112, and then 120. So the 60th observation is in the 50 to 55 class, which means I can draw this diagram here to help me determine the median. So we are interpolating between the 50 and 55 class. So somewhere along the way, we've got Q2, and we've got 53 observations up to 50 and 88 observations up to 55. They are the cumulative frequencies, and we're interpolating against the 60th observation. So I'll be doing the Q2 minus 50 over the 60 minus 53 being equal to 55 minus 50 over 88 minus 53. So let me write this down. Q2 minus 50 over the small opening of 60 minus 53 is equal to 55 minus 50 over the big opening of 88 minus 53. So we've got that Q2 minus 50 over 7 is equal to 1 over 7. I will cross multiply to get Q2 minus 50 is equal to 1, and therefore the median is 51 centimeters. Now for Q3, I will follow a similar approach. So for Q3, I will be evaluating 3n over 4. So it's going to be 3 times 120 divided by 4, which gives an answer of 90. So if I look in my frequency table, I see that the 90th observation is between 55 and 58. So in this case, I've got the 55, the 58, and Q3, we've got 88 observations up to 55 and 112 observations up to 58, and we're interpolating for the 90th observation. So once more, I'll be doing the small opening over the small opening being equal to the big opening over the big opening. So I've got Q3 minus 55 over the 90 minus 88 is equal to 58 minus 55 over the 112 minus 88. So Q3 minus 55 over 2 is equal to 1 over 8, and if I cross multiply, I get Q3 minus 55 being equal to 0.25, which means that the upper quartile Q3 is 55.25 centimeters. Remember, we're trying to find the interquartile range, which is simply Q3 minus Q1. So we've got 55.25 we just found minus the 45 that was given, which gives an answer of 10.25 centimeters for the interquartile range. In part D, we're given a formula for determining the skewness of measuring skewness, and we need to calculate this measure and describe the skewness for this data. So we've got Q3, which was 55.25, minus 2 times the median Q2, which was 51, plus the lower quartile, which was 45, over Q3 minus Q1, which is 55.25 minus 45. This gives an answer of minus 0.171, which is less than 0, and therefore we conclude that there is negative skewness. In question 2, the production cost C million pounds of a film. The total ticket sales T million pounds earned by the film are recorded for a sample of 40 films. We've got the summary statistics here, and we need to find the exact value of STT and SCT. Well, remember that STT is simply the sigma t squared minus the sigma t all squared divided by n. So in our case, it's going to be 82,873 minus 1,361 squared divided by n, which was 40. And this gives an answer of 36,564.975. Now for SCT, the corresponding formula is the sigma CT minus the sigma C times the sigma T over n. So in this case, the sigma CT is 83,634 minus 1,634 times the 1,361 over 40, which gives an answer of 28,037.15. In B, we need to calculate the value of the product moment correlation coefficient, and we know that the formula says that the R, the PMCC, is given by SCT over the square root of SCC times STT. So in our case, we've got SCT to be 28,037.15 over the square root of 28,732.1, which is the SCC that was given, times the 36,564.975 that we found in part A. So if we plug this on the calculator, we get an answer of 0.865, correct to 3 significant figures. In part C, we need to give an interpretation of the answer to part B. Well, we found the value for the PMCC that is positive and close to 1. The fact that it is positive means that we are looking at positive correlation, which means that as the production cost increases, the ticket sales also increase. Be careful here, you need to give your answer in context, so you need to mention the cost and the ticket sales for you to get the mark. In part D, we need to show that the equation of the linear regression line of t on C is written as t is minus 5.84 plus 0.976 C, where the values of the intercept and the gradient are given to 3 significant figures. Well, let's start by stating that the equation of the line of best fit is t is equal to a plus bc, where b is the gradient and a is the y-intercept. Well, b is given by SCT over SCC, which in our case is 28,037.15 divided by 28,732.1, which gives an answer of 0.97581 dot dot dot, whereas the y-intercept A is given by t bar minus b c bar. Now t bar is the sum of the t's, which is 1361 divided by n, which is 40, minus the value of b, which is found 0.97581 dot dot dot, times the mean of c, which is 1634 over 40. Plug this on the calculator, get minus 5.83695 dot dot dot, and therefore we conclude that t is minus 5.84 plus 0.976 c as required. Please note that when you write out the values of b and a, you should be giving them to at least 4 significant figures to justify the rounding to 3/7 and therefore the agreement with the answer given in the question itself. In E, we need to find the expected total ticket sales for a film with a production cost of £90 million. Well, we mean that this simply means that C is 90. So when C is 90, I need to plug this on the calculator to estimate T. So T is going to be minus 5.84 plus 0.976 times 90. This gives an answer of 82. And therefore we conclude that the expected total ticket sales will be £82 million. And finally, in part F, we need to use the regression line to find the range of values of the production cost of the film for which the total ticket sales are less than 80% of the production cost. So essentially, we're being asked to solve T being less than 0.8C. I have multiplied by 0.8 to get 80% of the production costs. Now for T, I'll be substituting the equation of the regression line, so minus 5.84 plus 0.976C being less than 0.8C. If I collect the C's on the left-hand side, I get 0.176C being less than 5.84, and therefore get that C is less than 33.2, which means that we are looking for production costs being less than £33.2 million. 3, we're investigating the body length B centimeters, and we've got a random sample of 8 observations, which has been coded as X being B minus 21 over 2. And we've got the summary statistics for the coded data, and I need to find the mean of B. Well, I will start by finding the mean of the coded data. I'll be finding X bar. So X bar is the sigma X over N, which in our case is minus 1.2 divided by 8, which gives an answer of minus 0.15. Well, we know that the mean is affected in exactly the same way as the data is coded. So we've got that X bar is equal to B bar minus 21 over 2. So X bar was found to be minus 0.15, which is equal to B bar minus 21 over 2. I will cross multiply to get the negative 0.3 is B bar minus 21. And therefore we get 20.7 to be the mean of B. In part B, we're asked to find the standard deviation of B, and I will start by finding the standard deviation of X, which is given by the sigma X squared over N minus the sigma X over N all squared and all square root. So in our case, it's going to be 5.1 divided by 8 minus the negative 1.2 over 8 and all squared and then square root. Plug this on the calculator, get the standard deviation for X to be 0.7842 dot dot dot. Well, we know that when we add or subtract, the standard deviation is not affected, so the minus 21 plays no effect whatsoever. So we've got the over 2 being the only thing affecting the standard deviation. So we've got that sigma X is equal to sigma B over 2. So 0.7842 dot 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 is equal to sigma B over 2. And if I cross multiply, I get 1.57 to be the standard deviation for B. In part C, we've got that the 9th squirrel is added to the sample, and given that for all 9 of them the sigma X is 0, we need to find the body length of the 9th squirrel. Well, we know that the original sigma x was minus 1.2 and the new sigma x is 0. This simply means that the x value for the ninth squirrel must be 1.2 to take the sum from negative 1.2 to 0. And therefore, I'll use coding to find the original value for b. So we've got x is 1.2 is equal to b minus 21 over 2. If I cross multiply, I get 2.4 is equal to b minus 21, which means that we get b to be 23.4, and therefore the body length of the ninth squirrel is 23.4 centimeters. And in II, we need to determine the standard deviation of x for all 9 squirrels. Well, let's start with the fact that the new sigma x squared is given by the original sigma x squared plus 1.2 squared, which is the value for x for the 9th squirrel. So we've got this to be 5.1 plus 1.2 squared, which gives an answer of 6.54. And knowing that sigma x, the standard deviation of x, is given by the square root of sigma x squared over n minus the sigma x over n all squared, then this means that we've got this to be 6.54 over 9, because we've got 9 squares now, minus the 0 over 9 and all squared, and then all square root, which gives an answer of 0.852. In question 4, we've got the cumulative distribution function of a discrete random variable w taking values 6, 7, or 8 given by this expression here, and we need to find the expectation of w. Well, to do that, I will start by drawing up a table of values for w. I would start by determining the capital F of w, which is the cumulative distribution function for w, and then I'll proceed in finding the probability of w being each of these values here. Well, I can automate the process on the calculator. If I press menu, then it's option 9, table, and my f of x is simply the expression we've got for f of w. So it's gonna be brackets x plus 3 close brackets, and then another set of brackets x minus 1, and all of it over 77. I will leave the g of x empty, and I will start at 6 and I will end at 8, and I'll be stepping every one. So I will be evaluating this at 6, 7, and 8. So we get for 6 we get 45 over 77. For 7 I'm gonna go down to get 60 over 77, and for 8 I get of course 1 as expected. So this means that the probability of being equal to 6 is simply the 45 over 77. The probability of being equal to 7 is simply the jump from the 45 up to the 60 over 77, which is 15 over 77. And then for the 8 is the jump from the 60 over 77 up to 1, which is 17 over 77. Now that I've got the probability for each value of w, I will simply say that the expectation of w is going to be 6 times the 45 over 77 plus the 7 times the 15 over 77 plus the 8 times the 17 over 77. So as always, we multiply each value of the random variable with the associated probability and add them up, and this gives an answer of 73 over 11. In question 5, we've got the weight W grams of kiwi fruit grown on a farm being normally distributed with a mean of 80 and a standard deviation of 8. We've got the different classes here, and the kiwi fruit is selected at random, and we need to find the probability that this is large. So we need to find the probability that it's greater than 70. Well, let's start by defining W to be the weight. W follows normal 80,8 squared. We're being asked to find the probability of W being greater than 70, which is the probability of Z being greater than 70, and I'm deducting the mean of 80 dividing by the standard deviation of 8. This gives me the probability of Z being greater than minus 1.25, which is the same as the probability of Z being less than 1.25. So I'm going to the formula booklet, to the table of values for 1.25. I read off the value of 0.8944. And therefore the probability I was trying to find is simply 0.8944. In part B, we've got 35% of the kiwi fruit being jumbo, and we need to find the value of K to 1dp. We're looking at the table we had here. The jumbos are between 80 and K. So in other words, we have just been told that the probability of 80 being less than or equal to W being less than or equal to K is equal to 0.35, and I will split this into the probability of W being less than or equal to K minus the probability of W being less than or equal to 80, which is 0.35. I will standardize. I've got the probability of Z being less than K minus 80 over 8, and the probability of W being less than or equal to 80 is simply a half, because 80 was the mean. So half of them are below the mean and half of them are above the mean due to the symmetry of the normal distribution. So minus 0.5 is equal to 0.35, which means that the probability of Z being less than K minus 80 over 8 is equal to 0.85. Well, I will write this as the probability of Z being greater than K minus 80 over 8 being equal to 0.15, so I can use the small table of probabilities on the normal distribution to determine the corresponding Z value. So looking at the table of values for 0.15, we get a Z score of 1.0364, which means that K minus 80 over 8 is equal to 1.0364. If I cross multiply, I get K minus 80 is 8.2912, and therefore K is equal to 88.321 decimal place. In part C, we are told that 75% of tiny kiwi fruit weigh more than Y grams, and we need to find the value of Y, giving our answer to 1dp. So I will start by drawing a bell-shaped curve. We've got the center, the mean at 80. Well, we know that it's surely a tiny kiwi fruit, and we know that tiny kiwi fruits are less than 66 grams. So we are surely on the left-hand side as shown, shaded here. And we have that the probability of being greater than Y is 0.75, which means that what I'm shading here in red is the 0.75. In other words, the probability of W being greater than Y, given that W is less than 66, so it's conditional probability. We know for sure that it's a tiny kiwi fruit, and therefore the weight is less than 66 grams. It's going to be given by the intersection, so the probability of Y less than W less than 66 over the probability of being a tiny kiwi fruit, which is the probability of W being less than 66. I will split the inequality in the numerator, so it's the probability of W less than 66 minus the probability of W less than Y over the probability of W being less than 66. I will proceed by standardizing, so we've got the probability of Z being less than 66 minus 80 over 8 minus the probability of Z being less than Y minus 80 over 8, and all of it over the probability of Z being less than 66 minus 80 over 8. Well, this leads to the probability of Z being less than minus 1.75 minus the probability of Z being less than Y minus 80 over 8, and all of it over the probability of Z being less than minus 1.75. Well, I can write the probability of Z being less than minus 1.75 as simply 1 minus the probability of Z less than 1.75 minus the probability of Z less than Y minus 80 over 8, and all of it over the 1 minus the probability of Z being less than 1.75. Going to the table of values for the normal distribution, we read off for 1.75 the value of 0.9599. Therefore, we've got 1 minus 0.9599 minus the probability of Z less than Y minus 80 over 8, and all of it over 1 minus the 0.9599 to be the right hand side, and we know that this probability is 0.75. So if I cross multiply, I get 0.030075 is equal to 0.0401 minus the probability of z less than y minus 80 over 8. I will collect the probability of z on the left hand side. So we've got probability of z less than y minus 80 over 8 is equal to 0.0100. And so we've got that the probability of z being less than the 80 minus y over 8 is equal to 0.99. So looking into the table of values, I'm trying to get a probability which is as close as possible to 0.99. We see that we need to go over here. 0.9898 is the closest, so we get 2.32. And therefore we have 80 minus y over 8 is equal to 2.32. I will cross multiply to get that 80 minus y is equal to 18.56, and therefore we conclude that y is 61.4. On 6, we've got the Venn diagram here showing events A, B, C, and D with the associated probabilities, and we need to write down the value of probability of A. Well, the probability of A is all of this, so we can simply say that the probability of A is simply the 0.13 plus the 0.12, which is of course 0.25. Now for the probability of A given B, this is conditional probability. We are surely in B, so I'm going to tick the B. And we are wondering what's the probability we are in A as well. So it's exactly that. Well, since the B is a subset of A, being in B surely means I'm in A. Another way you could do it is simply use the formula for the conditional probability. So the probability of A given B is the probability of A intersection B over the probability of B, which is of course 0.12 over 0.12, which is 1. Now for the probability of A given C, we are surely in C. So what's the probability we are in A? Well, A and C are disjoint circles on the Venn diagram. They are mutually exclusive events. So if I'm in C, this surely means that event A cannot take place, and therefore the probability of A given C is simply 0. We're then told that the probability of B dash intersection D dash is 7 over 10, and the probability of C given D is 3 over 5, and we need to determine the exact values of Q and R. Well, let's start with the first piece of information. The probability of B dash intersection D dash means I'm surely outside of B and outside of D. So it's this, and this. So we've got that 0.13 plus P plus S is 7 over 10, which means that P plus S is 0.57. And then for the probability of C given D, it's conditional probability. We are surely in D. So what's the probability we are in C? It's the intersection. So the probability of C given D is equal to Q over Q plus R, what I know for sure to have happened. And this is equal to 3 over 5. Well, I can cross multiply to get 5Q is equal to 3 times Q plus R, and therefore 5Q is 3Q plus 3R, which means that 2Q is equal to 3R. Now we also know that the sum of the probabilities should be equal to 1, so this means that we've got 0.13 plus 0.12 plus P plus Q plus R plus S is equal to 1, which means that P plus Q plus R plus S is equal to 0.75. Now we've got P plus S is 0.57, so I can replace P and S with the 0.57. So 0.57 plus Q plus R is 0.75, and therefore Q plus R is 0.18. I can then proceed into multiplying everything by 2 to get 2Q plus 2R is 0.36, because I'm solving now simultaneous equations in Q and R. So we've got 2Q is equal to 3R, so 3R plus 2R is 0.36, meaning that 5R is 0.36, and therefore R turns out to be 0.072. And now that I've got R, I can replace into the Q plus R is 0.18, and therefore we've got that Q plus 0.072 is equal to 0.18, which means that Q turns out to be 0.108. Given also that the probability of B union C dash is 5 over 8, we need to find the exact value of S. Well, let's look at the Venn diagram. We've got the probability of B union C dash. So I'm in B or outside of C. So I'm here, and outside of C is this, and this. So 0.13 plus 0.12 plus R plus S should be 5 over 8. Let me write this down. We've got 0.13 plus 0.12 plus R plus S is equal to 5 over 8, which leads to R plus S is equal to 0.375. Well, we know that R is 0.072. So 0.072 plus S is 0.375, which means that S turns out to be 0.303. In question 7, we've got the random variable x, which can take values 0, 5, or 10 with the associated probabilities as shown in the table here. And given that the number selected is not a 5, we need to write down the probability that it is 0. Well, if it's not a 5, then it's either a 0 or a 10, and we're asking what's the probability that it's a 0. So it's the intersection, the 0.1, over what we know to have happened for sure, the 0.1 plus the 0.7, which gives an answer of 1 over 8. We are then asked to show that the expectation of x squared is 75. So to find the expectation of x squared, I'm squaring each possible value of x and multiplying with the associated probability. So 0 squared times 0.1 plus 5 squared times 0.2 plus 10 squared times 0.7, which if I plug on the calculator, I get 75 as required. We are then asked to find the variance of x, and to do that I will start by finding the expectation of x, which is simply the values of x times the associated probabilities and all added up. So it's 0 times 0.1 plus 5 times 0.2 plus 10 times 0.7. This gives an answer of 8. Well, we know that the variance of any random variable is given by the expectation of x squared minus the square of the expectation. So it's gonna be 75 from part B minus the 8 squared, which gives an answer of 11. In part D, we are asked to find the variance of 4 minus 3x. We're looking at coding essentially here. The 4 here is simply a constant which is added, so it's not having an effect on the variance. However, the negative 3 is multiplying the x, so it is having an effect on the variance. So we have that the variance of 4 minus 3x is equal to minus 3 squared times var x. Well, this is 9 times 11, which works out to be 99. We now have that Bruno and Charlie each independently select a number at random from the distribution of x, and we need to find the probability that the number that Bruno selected is greater than the number that Charlie selected. So to approach this question, I will draw a tree diagram showing all possibilities. So this is what Bruno could have selected and what Charlie could have selected. So we want the number that Bruno selected to be greater than the number that Charlie selected. This means that we've got the 5-0 scenario, the 10-0, and the 10-5 scenario. So to find the probability required, it's going to be the 0.2 times the 0.1 plus the 0.7 times the 0.1 plus the 0.7 times the 0.2, which gives an answer of 0.23. We then have that the Vega multiplies Bruno's number by Charlie's number to obtain a product D, and we need to determine the probability distribution of D. Well, I will revisit my tree diagram here and determine the corresponding values for D. So when they both pick 0, it's going to be a product of 0. And obviously, if Bruno selected 0, then whatever Charlie selected will give me a product of 0. The 5-0 scenario is giving me D is 0. Then I've got D is 25. Then D is 50. then D is 0, D is 50, and D is 100. So I will proceed in finding the associated probabilities for each possible value for D. So for the probability of D is 0, this is simply gonna be the 0.1 times 0.1 plus the 0.1 times 0.2 plus the 0.1 times 0.7 plus the 0.2 times the 0.1 plus the 0.7 times the 0.1, and this gives an answer of 0.19. For the probability of D being equal to 25, this is only through the 5-5 scenario, so 0.2 times 0.2, which is 0.04. The probability of D being equal to 50 is through the 5-10 and 10-5 scenario, so 0.2 times 0.7 plus the 0.7 times the 0.2, which gives an answer of 0.28. And finally, the probability of D being 100 is simply through 10-10, so it's 0.7 times 0.7, which is 0.49. So the only thing missing is to put everything nicely in a table. So the associated probabilities are 0.19, 0.04, 0.28, and 0.49. And we can add them up to confirm that they are adding up to 1, and therefore this is a valid probability distribution.